And so the engineering team, again, going back to that 30 years of experience, knows where those critical reliability points are and is able to drive a solution that really meets our customer need. So those 5 principles, I hope you hear and you experience them through the entire day. It starts off with the customer, it's innovation, it's time to market, value to the customer in terms of hitting the cost points, and then reliability and quality. In fact, you're going to see a lot of the quality dimensions in terms of how we validate our systems. So how does that translate into product? Jim talked about, gee, we got handles on this thing so I can pick it up. And those of you who were in Los Angeles a year and a half ago, you saw me carry it up. In fact, you saw me last March carry it up too, but it really wasn't the Workstation. It wasn't the Z8. We were talking last night. It was the case, and it was this little guy inside over here. But the concept of handles was just, it was like so natural. Once we heard, like, wow, why didn't we think of this sooner? But it goes far beyond that in terms of listening to the customer. Things like doors that just snap in and out. It sounds like a car door. It sounds so secure, and it's just convenient then to get inside. You've all seen the inside. In fact, Rosie on her video did a much better job than I did in terms of the demo. Those of you who've seen her on YouTube, she's fantastic. But the design in here, I've talked about the fact that we manage airflow. You're going to downstairs. You're going to see one of our systems that's got over 100 thermocouples mounted in it. We're doing a bunch of testing, stress testing right now. One customer wants to put more hard drives and wants to put a lot of Tesla cards in there. So we're actually validating in terms of all the thermal characteristics to make sure that the profiles match our needs. The whole idea of the green touch points, the fact that it's easy to access things inside, are all dimensions of innovation. The engineering team knew that they had to manage airflow. That was an engineering requirement, but then they got innovative and said, well, we can actually make something that looks nice on top of it. And so they took a little bit of time. I have an industrial engineer on staff, and he said, hey, Terry, we can do this, this, and that. And I said, Tom, how much more is it going to cost? He says, 3 pennies. I said, done. Okay, we can do that. We were going to have to do a cowling anyways, but now we could add just a little bit of design to it. Things like that. Things like blind make connectors. Now you say, well, Terry, you got blind make connectors here. Why don't you have them here? Because it would be nice to have them here. I'll go back to that value. Principle number 4 is that blind make connectors cost more. It's a more precise technology, and if the price comes down, I'm going to put them here as well. So if I can drive the industry to new price points, I'm going to make them more available across the platform. But what we said is, gee, we can afford it here, but we're not going to drive it down there. Another example of time to market with key technologies. We were the first to bring solid state technology into our workstations. Now I will freely admit, we aren't selling a bazillion of these. Solid state is still very expensive. But for those customers who need, shake and shock reliability, in other words, they need to have the machine operating, but it's going to vibrate and you wouldn't want to crash heads, this is perfect. Or if you've got someone who's in an environmentally challenged environment for which you're worried about heat and so forth, heat and humidity, again, solid state comes into play. But it goes beyond just saying, okay, we're going to put solid state drives in here. I had an engineering team that we spent 9 months with prototypes of solid state technology before we released the first one, because we had to validate the workstation characteristics. One thing that people don't readily know about solid state has a finite life. Okay? It wears out. Different than spindle. It wears out. Well, we went through all the paces that a typical workstation customer would use, all the reads writes, to understand where were the limits. And I mentioned this customer, we were up in Minnesota. They were looking at solid state for this particular design that they want to do. And they were looking at a particular design, and we came in and the engineering team says, if you do that, you're going to run out of life. You're going to have to replace these drives after 4 years. Well, this medical device is intended to last 10. That became a warranty issue for them. Having that knowledge, applying that knowledge to the customer and giving them that insight is really critical in what I'll call developing the value proposition for them to say, I want to do business with HP. So that when they buy from us, they're saying, I'm getting more than just the box. I'm not just getting a commodity. I'm actually getting a relationship that can help my company be successful. So that's another example. I put that one in correctly. There we go. This was another fun piece of innovation. And it goes back to the customer. We had a customer who takes our workstation out of its packaging, mounts it into their environment, and then ships it in a good, a well-cushioned environment, but it was different than ours. And it was causing enough vibration such that these heavy cards were coming out. Now, I've got some NVIDIA FX 4800s in here right now. And they would come out and they'd jiggle inside of here. Well, we created in the old workstations all kinds of mechanical arms and springs to try and hold this down. And when the engineering team was given the opportunity to redesign it, they said, Terry, we're going to get rid of all that stuff. All that stuff is complicated and it works marginally well. We're going to create something that is much more efficient. And so instead of using all plastic as we did up in this column up here, there was no structural need. This had some structural needs. This is actually sheet metal. And so why is it sheet metal? Because it actually provides mechanical rigidity that when you press it down, it actually forces the I/O card in 3 points, back here, in the middle, and on top. In the middle, it's done with something as simple as little bitty plastic tabs. So once again, that idea of listening to your customer and then innovating came into play. So again, those principles keep getting intermixed. At the same time, the question was, how much can we afford? What were the costs? How do we drive the costs to an appropriate level? And so we drive all those principles on a continuous basis. By the way, this also affects Principle 5, quality. If I can securely have those cards in place, then they don't move around. And some of you who have been, especially to some of the emerging market countries like India and China, some of the roads in the back areas aren't very good. Big potholes and so forth, and a big old truck that doesn't have very good springs, or the springs are so stiff because the roads are so bad, otherwise they break the suspensions, that workstation is really bouncing around. Now all of a sudden we've improved the reliability, ensured that we don't have a system that is either DOA or you have to re-plug in all the cards when it arrives. So those principles keep getting intermixed throughout the entire process. And I can go on and on. I mean, there's all kinds of little things. I talked about the little parking garage here that we have, for the cabling. When we looked at the acoustics, the fact that we have a power supply that you can remove, and that all the connectors are in the back, which means all the wires are on the back side of the motherboard, they're not on the front side of the motherboard, meant that we could reduce a lot of air restrictions inside, which improved the acoustics, which allowed us to drive down the amount of sound pressure, which meant in the office environment, it was a much more pleasant machine to have than we had in the past. So again, customer said, wow, it's acquired a machine. Well, we get more reliability because we're cooling it more efficiently. And so there's all these win-wins. And so again, those crazy principles just keep intermingling all the time. And then the idea of serviceability is being able to get a customer back up and running very quickly, the fact that I can ship them the power supply, versus having a service person come on site and getting that scheduled when it's convenient for the customer. Don't have to do that. I can, overnight, I ship the power supply if the power supply is bad, and get it in their hands the next day. All they have to do is pop it in, and they send the other one back to us and take care of it. So that's what you're going to hopefully hear today, and what you're going to see. Let me tell you a little bit about what you are going to see. We're going to break into 2 groups, and Jeff's group is going to start off actually in our demo center, correct, Jeff? So we're going to give you kind of a demo of performance and leading edge performance kinds of things that we're working on with our ISVs as well as with our partners. The group that's going to go with me, we're going to start on the lab tour. And Jeff's group will actually be right behind me, so you'll be on the lab tour. So the lab tour will kind of go like this. We're first going to take you into what we call the turn-on lab. And this is what I'll call the heartbeat and the soul of my organization. All of our desks basically surround the turn-on lab. It is where we bring a new design or new technology to life. It's where we turn it on the first time. It's a pretty simple process, but it's incredibly complex because as you move down the different aisles in the turn-on lab, you're going to see the mechanical design, the power